Bismillah Rahman Rahim. This is our second online lecture. Last time we talked about indirect utility function, and today we'll explore the properties of indirect utility function. As we already discussed, that utility is the function of commodities. Commodities are the functions of prices and income. Therefore, utility is indirectly the function of prices and income, which is called the indirect utility function. So the first property of indirect utility function is this, that it is homogeneous of degree 0 in prices and income. We already know it, that what's the idea of homogeneity? When we say any function is homogeneous of degree 0, it means that if all variables change by same proportion, then the value of that particular function is unaffected. Now, in case of indirect utility function, if prices of all the commodities which are included in the purchasing plan of consumer and the income of consumer change by the same proportion, then utility will be unaffected. It's very simple to understand that if prices of all the commodities and income of buyer change by the same proportion, then there'll be no effect on the budget constraint of the consumer. His real income, his purchasing power will remain the same. So if purchasing power remains the same, then the amount of goods which he or she will purchase will remain the same. And if amount of goods is the same, then definitely the utility level will also be the same. Mathematically, if we multiply all prices and income with any constant, then the same constant can be factored out with power 0. Now, for example, our indirect utility function is the function of prices and income. If we multiply all the prices and the income with any constant, say, for example, in this slide, we have taken that constant as alpha. Alpha is a constant which is greater than 0. It can be a fraction, it can be a whole number. So we have multiplied all the prices with alpha and income with alpha. The same alpha can be factored out with power 0. So we'll come up with the same utility function. This is called, that indirect utility function is homogeneous of degree 0 in prices. The second property is indirect utility function is non-decreasing in income, which means that with the increase in income, utility is likely to increase. However, it is always non-decreasing. So what we'll do is this, we'll take a simple indirect utility function and then we'll differentiate that indirect utility function with respect to the income. If the answer is non-negative, then it means that indirect utility function is non-decreasing in income. Okay, a utility function is written on the slide. We have restricted ourselves to only two commodities. So how we'll read it? Utility is the function of x1 and x2, and x1 and x2 are the function of prices and income. Okay, now we are interested in the derivative of this indirect utility function with respect to income. We cannot directly differentiate it with respect to income because utility is the function of commodity and commodity is the function of income. Therefore, we'll have to use the chain rule. We'll differentiate utility with respect to commodity and then we'll take the derivative of commodity with respect to income. So using chain rule, we took the required derivative. Curly v over curly m is equal to curly v over curly x1 into curly x1 over curly m, which means that we partially differentiated utility with respect to x1 and then x1 with respect to m. This is what we done for first commodity, and same we did with the second commodity, curly v over curly x2 into curly x2 over curly m. So this is equation number 1. Now, from profit maximization, we know the first order conditions. So according to first order conditions, we already know it that curly v over curly x1 is equal to lambda into p1 and curly v over curly x2 is equal to lambda into p2. Therefore, we'll substitute the first order conditions in this equation number 1. So you can see here the the last equation, we have substituted the first order conditions in equation number 1. Now we can simply take lambda common from equation number 1. We took lambda common and called it equation number 2. Okay, recall the budget line, the budget constraint. It's equal to m is equal to p1x1 plus p2x2, differentiating it with respect to m. So the derivative of m with respect to m is 1 is equal to p1 as it is, and then the derivative of x1 with respect to m plus p2 as it is, and then the derivative of x2 with respect to m. Now you can see here that what we got is exactly the same term which is within the bracket in equation number 2. So the term which is within the bracket in equation number 2 is in fact equal to 1. Therefore, substituting it in equation number 2, if it's equal to 1, we'll get lambda into 1. Lambda into 1 is lambda. Therefore, the derivative of utility with respect to m is equal to lambda. And regarding lambda, we know that it's positive. Therefore, indirect utility function is non-decreasing in income. Property number 3, indirect utility function is non-increasing in price. It means that if price of any commodity increases, then as a result, utility is likely to decrease. However, strictly speaking, indirect utility function is non-increasing in price. So for this, we'll differentiate indirect utility with respect to one of the price. So we have done it for P1. Here again, we'll have to use the chain rule because utility is the function of commodity and commodity is the function of price. So we use the chain rule. Curly v over curly p1 is equal to curly v over curly x1 into curly x1 over curly p1 plus curly v over curly x2 into curly x2 over curly p2. This is equation number 1. Now from first order conditions of utility maximization, we'll substitute curly v over curly x1 with lambda p1 and curly v over curly x2 with lambda p2. After substituting, we can take lambda common, which is here equation number 2. Once again, recall the budget constraint. This time we'll differentiate it with respect to P1. So that's dm over dp1. Okay, the first term is P1 into x1. P1 is there. X1 we know it's also the function of P1. Therefore, we'll have to use the product rule. So we applied product rule. The derivative of P1 is 1. X1 came there and then plus P1 as it is, and the derivative of x1 is curly x1 over curly P1. Now we come up with the second term. The second term of the budget constraint is P2 into x2. P2 is not the function of P1. However, x2 is the function of P1. Therefore, P2 came as it is, and then it's curly x2 over curly P1. Further, we know that dm over dp1 is equal to 0. And after some simplifications, we got minus x1 is equal to p1 into curly x1 over curly p1 plus p2 into curly x2 over curly p2. This is exactly the same term which is within the bracket in equation number 2. Therefore, we substituted it in equation number 2 and we got curly v over curly p1 is equal to minus lambda into x1. And similarly, we can do it for the price of second commodity. It will be curly v over curly p2 is equal to minus lambda into x2. The next property is indirect utility function satisfies Roy's identity. Before discussing what the Roy's identity is, let's recall property number 2 and property number 3. Property number 2, curly v over curly m is equal to lambda. We did it. From property number 3, we got curly v over curly pi is equal to lambda xi. Now, if we simply take the ratio of these two terms, then you can see from here that lambda and lambda will cancel out. This is what we have done. We have taken ratio of the two partial derivatives, that is curly v over curly pi divided by curly v over curly m is equal to minus x1. So this is the Roy's identity. So what is Roy's identity? That the ratio of the partial derivatives of indirect utility function with respect to price and income is equal to a Marshallian demand function with a negative sign. So from here we got one more information that Marshallian demand functions can be obtained from indirect utility function also. According to the next property, indirect utility function is quasi-convex. Okay, now The question is this: what do we mean by quasi-convex? Recall that we have already discussed it, that utility function, the direct utility function is quasi-concave. Regarding quasi-concavity, we discussed that the linear combination on its contour set yields the higher value. But if the function is quasi-convex, then it will be other way round. It's written here. Look at the line number 1 and 2. For quasi-convex function, the linear combination of any 2 points on its contour set yields lower value. If it yields a higher value, then the corresponding function will be quasi-concave. And if it yields low value, then the corresponding function will be quasi-convex. So in case of indirect utility function, the property is that it is quasi-convex. So indirect utility function is quasi-convex in prices. What it means, if the linear combination of any two consumption bundles on an indirect indifference curve yields indifference curve with relatively low utility. That's the condition. Let's discuss that. What's the fundamental difference between the ordinary indifference curve and the indirect indifference curve? Ordinary indifference curve is the one which is defined in the space of commodities. In that, along horizontal axis, you take one commodity and the other commodity is taken along the vertical axis. Indirect indifference curves are those which are defined in prices space. So you can see here in the figure that we have shown one indifference curve. Along horizontal axis we took P1 and along vertical axis we took P2, and here we have one indifference curve. Now if we take the linear combinations of this indifference curve, then those linear combinations will be along the dotted line as shown in the figure. So any indifference curve on this dotted line will will be inferior to this particular indifference curve. Or putting it in another way, we can say that any indifference curve higher than this one will yield lower utility. This is the property which is known as indirect utility function is quasi-convex in prices. Now we will take one illustrative example to understand the properties of indirect utility function in a better way. In our previous class, we derived one indirect utility function, and the expression of that indirect utility function is written here. V is equal to m power 4 divided by 16 p1 square into p2 square. So on this particular indirect utility function, we'll apply all the properties, starting with property number 1, that indirect utility function is homogeneous of degree 0 in prices. So we multiplied m and the two prices with a constant alpha. You can see here we have multiplied with it alpha, and after some simplifications, the same alpha is factored out with power 0, which means that utility is unchanged if all prices and income change by same proportion. Okay, now coming up to second property, indirect utility function is non-decreasing in income. We have the indirect utility function. We'll differentiate this indirect utility function with respect to income. If the answer is non-negative, then the property will hold. So the indirect utility function is m power 4 divided by 16 p1 square into p2 square. We differentiated it with respect to m and got 4 into m power 3 divided by 16 p1 square into p2 square. M and the p's are positive, therefore the result is greater than 0. However, we are further going to simplify it, and multiplying and dividing it by m will enable us to write it as 4v over m. So the derivative of indirect utility function with respect to m is 4v over m. We know that v is the indirect utility function which is non-negative, m is also non-negative. Therefore, or indirect utility function is non-decreasing in income. Okay, now property number 3. Indirect utility function is non-decreasing in price. It means that we'll differentiate our indirect utility function with any of the price. We are doing it for P1 and our answer should be non-positive. So the indirect utility function is written as m power 4 into P1 power minus 2 into P2 power minus 2 whole divided by 16. We differentiated it with respect to P1 and got minus 2 m power 4 into P1 power minus 3 into P2 power minus 2 whole divided by 16. So the term is clearly negative due to the negative sign. However, we have further simplified it, and after some simplification we got dv over d P1 is equal to minus 2 over P1 into V. So it is in fact 2V over P1 with a negative sign. V and P1 are always non-negative. Therefore, due to the negative sign of this expression, it is negative. So we can say that indirect utility function is non-increasing in price. Now we are going to apply Roy's identity. We already know that dv over dm is 4v over m, dv over dp1 is minus 2v over p1, dv over dp2 is minus 2v over p2. So Roy's identity is simply the ratio of the two partial derivatives. That's the ratio of the derivative of indirect utility with respect to price and income. So we have taken the two ratios and we got minus m over 2p1. We did it for the first commodity, and we can see here this is exactly the Marshallian demand function. You can verify it from your previous example that it's the Marshallian demand function, and similarly if we do it for second commodity, it will be the Marshallian demand function for second commodity. So Roy's identity is well verified. Now we have to verify that indirect utility function is quasi-convex. For this, we'll have to work out at least two indifference curves corresponding to this indirect utility function. In order to work out the indirect indifference curves, we'll have to fix the utility level at the given income. So to derive the first indifference curve, we assume that m is 10 and the level of indirect utility is 6.25. So in the equation of indirect utility function, in place of v, we substituted 6.25, and in place of m, we substituted 10. And then after some simplifications, we got an equation explaining the relationship between P1 and P2. The equation is P1 into P2 is equal to 10. Okay, here one thing is very important, that we took two imaginary values of m and v. You can take any value, whatever you want. After substituting those two values into the indirect utility function, you will get an equation showing the relationship between the two prices. We got an equation showing the relationship between two prices. P1 into P2 is equal to 10. So we have P2 is equal to 10 over P1. Now we'll work out few combinations of P1 and P2. For this, we took 5 different values of P1 from 1 to 5. P1 is 1, then P1 is 2, then P1 is 3, P1 is 4, and P1 is 5. By assuming the different values of P1, we got the values of P2. For example, if we put P1 is equal to 1, we'll get P2 is 10. If we put here P1 is equal to 2, we'll get P2 is equal to 5. And in this way, we got different combinations of P1 and P2. So these are the different combinations of the two prices at which the utility level, the indirect utility is 6.25 when the income is 10. Now, if we plot these combinations, the combination of prices, then we'll get the indirect indifference curve. We have worked out one indifference curve. We need one more indifference curve. So with the same indirect utility function, we'll work out another indifference curve with the same income. So we took income 10, we are not changing it. However, to derive indifference curve number 1, we took v is equal to 6.25, and now we have taken v is equal to 12.5. So we substituted these two values, that's m is equal to 10 and v is equal to 12.25, in the equation of indirect utility function, and then solved it for P1 and P2. We got an equation explaining the relationship between P1 and P2. The equation is P2 is equal to 7.071068 divided by P1. So again, we took the 5 different values of P1 ranging from 1 to 5. Corresponding to each value of P1, we got a value of P2. For instance, when P1 is equal to 1, we got P2 is equal to 7.07. When P1 is equal to 2, we got P2 is equal to 3.54, and so on. When P1 is equal to 5, we got P2 is equal to 1.41. So these are the 5 combinations of prices and income. The first combination is 1 and 7.07. The second combination is 2 and 3.54. The last combination is 5 and 1.45. At all these combinations, the utility level is same and the income is also given. So if we plot these combinations, we'll get an indifference curve. The two indifference curves are plotted here. We can see that the higher indifference curve is the one at which v is equal to 6.25, and the lower indifference curve is one at which v is 12.5. In both, m is equal to 10. So we can see from here that for indifference curves in prices space, higher the indifference curve, lower the level of utility. In this particular example, the lower indifference curve, which is more closer to origin, has the indirect utility is equal to 12.5. The higher indifference curve, which is away from origin, relatively away from origin, has the utility level 6.25. So it means that if we have the indifference curves in prices plane, which are called the indirect indifference curves, then higher the curve, lower the level of utility. This figure is just replica of the previous one with only one difference. Here along the lower indifference curve, we took 2 points and joined them with a straight line. We took 2 points on the lower indifference curve and joined them with a straight line. The straight line is a dotted line which you can see in this figure. In fact, this straight line is giving us the linear combination of the 2 points which we selected on the lower indifference curve. Make it clear that this is not the ordinary indifference curve. This indifference curve is defined in prices space. It's the indirect indifference curve. So I'm telling it once again. Along the indifference curve, which in this figure is the lower one, where the utility level is 12.5, we took 2 points and worked out the linear combination of those 2 points. In this particular case, all the points which are on the dotted line will yield the lower level of utility as compared to the lower indifference curve. By chance, we have one point on the dotted line which is reflecting higher indifference curve where the utility level is 6.25. So it's very clear from here that higher the indifference curve is, lower the level of utility. So when we say that indirect utility function is quasi-convex, it means that the linear combinations of any indirect indifference curve will yield the lower level of satisfaction. This is exactly opposite to what we saw for indifference curve defined in commodity space. So that is all about the properties of indirect utility function. Kindly note that there is one mistake in previous slide. In previous slide I wrote further it can also be seen that the dotted line giving linear combination of 2 points on lower IC yield higher satisfaction, it should be yield lower satisfaction. It should be yield lower satisfaction.